Well, we had product rule last time, and if u was some function f of x and g of x equals v, we like to write it in shorthand notation, u and v, so that I don't have to rewrite f of x, g of x each and every time. And last time, if we have the products of two functions, the rule was quite simple. It's u v prime plus v u prime. And the point that we wanted to stress is that you cannot simply take the derivative of u and the derivative of v separately and multiply them together. That's wrong. So, going along the same lines,
so effectively, this is the same thing that we learned inside of pre-calc. We were talking about cosine and sine and all those. Just now applied to primes.
we have u divided by v. Well, the rule is quite simple. Last time I took this elaborate approach to prove that the derivative of u times v, when both u and v are functions of x, would equal to u v prime plus v u prime. This time, I want to show this, but I want to keep things simple. So, in other words, we know this works. So I'm going to make use of the product rule to verify if the quotient rule is correct. Well, could I use the elaborate approach? Sure, but I'm just being lazy. If you want to know more, come talk to me. So I have u divided by v, but I want to use product rule and find its derivative. So how do I go from here to a product?
You can set v in the very least to the power of -1, and that will put v on the denominator.
Okay. Yes. Now I don't want to use another u, v again, so I'm going to call u1 to the u and v1 as v inverse.
Use product.
What?
No, I was just writing that.
u1 prime would be u prime. v1 prime, if you treat that v as is, you would have -1. If v is just, v, when you take the derivative, you have -1, v raised -2. Correct. But later on, I'll show you why this is true. We have to multiply it by v prime of x. Put a note. We will talk about chain rule in 3.4, but this is a good way to, get ahead of the curve. So since v is a function of x, I'm treating v as this, use the power rule, but then realize, well, v is a function of x, so I have to take its derivative also. That's just how chain rule is going to work. Put the star, and I'll explain this once the time comes. So standard process, u v prime. So this times, oops. So that is the rule in terms of U1 and V1. So going to use the formula U multiplied by that V raised to -2 V prime plus V1, which is V inverse, multiplied by U prime. Good. I want to get rid of that negative thing. So U V prime divided by when v raised -2 goes from the numerator to the denominator, it will become positive. U prime, when I move that from the numerator to the denominator, it would become positive what here? V.
Oh. Same thing.
Now I want to combine them together. How would I combine them together?
You'd have to.
I have to do what?
You'd have to make a denominator.
So multiply and divide the by v so that I get a common denominator. So negative u v prime over v squared plus v u prime over v squared. Do I have a common denominator? Yes.
Which you can then restructure that into what we get for quotient.
Yes. If I rewrite that, it's exactly the same as that. Do you agree? They are one and the same. I just reverse the order because it is addition. So it's v u prime minus u v prime. So this is the easier way of, realizing that this rule is true. Of course, if I didn't know chain rule at all, the process is elaborate. We have to do the exact same thing that we did last time. U plus delta U, V plus delta V, common denominator, simplified, combined, all of that. But I just wanted to give you a heads up as to what chain rule is. Chain rule simply states that if V is a function of X, then we treat V like any other variable. Find its derivative, which is -1, V raised -2, but multiply by the derivative of V itself. So you've got to multiply by V prime. Are we clear? Yes.
That's supposed to be f of x or g of x.
This one. Let's just go on the function.
Oh, I apologize.
F of x is in the numerator, g of x is in the denominator.
Ah, okay.
So how do we go about finding the derivative of this function? Use quotient. Okay, numerator. X cubed plus x minus 2. Denominator. X squared. What is the derivative of x cubed? 3x squared. derivative of x, derivative of -2, derivative of x squared. And now I could find y prime easily. V u prime minus u v prime divided by v squared. So x squared multiplied by u prime minus u multiplied by v prime, which is 2x. Divide the entire thing by v squared, which is simply x squared. Squared. Yes, v is x squared, square of that. I am going to distribute and simplify x squared times 3x squared is 3x raised 4. X squared times 1, x squared minus x cubed multiplied by 2x, negative 2x raised 4, negative 1 times x times 2x, negative 2x squared, negative times negative, positive, 2 times 2x, 4x. Divide the entire thing by x raised 4. Well, I could combine those two terms. 3x raised 4 minus 2x raised 4 is x raised 4. X squared minus 2x squared, negative x squared, plus 4x.
How exactly did you remove the 3?
Come again?
Sorry, because you said at the very least you can't, you said at the very least that you used x4 and then at the very least you got 3x4.
What do you mean?
How exactly did you get 3x to?
3x raised 4, I distributed.
No, I mean, how did you get that to the x raised 4?
You subtract 2x to the 5.
3x raised 4 minus 2x raised 4.
Oh my god, I didn't see that. Slow down, idiot.
Well, x raised 4 divided by, well, I can split this up. Oh, I see.
What I originally thought was that you somehow cancel out x of 45 on this. That's why I was confused.
It's okay. Well, I can simplify this, right? What is x raised 4 away? What did I do? Since I have a common denominator, I just split it up. So x raised 4 divided by x raised 4 is 1. X squared over x raised 4 is
1 over x squared.
and the last term 4 divided by x cubed. This is great and all. I'm going to ask you to try something. We did quotient rule, did all this to get to that answer. My claim is that this problem can be completed by using power. Give it a try. Yeah. So if y equals x cubed plus x minus 2 divided by x squared, we did this using quotient rule. Great, we got the answer. And I asked you to try using power rule without even thinking about quotient rule. Well, since I have a common denominator, I could write it as x cubed over x squared plus x over x squared minus 2 over x squared. Yes? X cubed over x squared, if I cancel, I will have x. X over x squared, 1 over x minus 2 over x squared. Correct. I want to use power rules, so I want to convert those to powers. So x plus, if x moves to the numerator, it would become x raised to -1. If x squared moves to the numerator, it will become x raised to -2. Now it's easy to do power rule. Derivative of x is 1. What is the derivative of x raised to -1? -1 moves to the front, x raised -1, -1, that is -2. -2, move -2 to the front, x raised -2, -1, -3.
You see, for some reason, I thought we were asking us to do was to find a way to do it in one step. We got me stuck.
So -1, when that moves from the numerator to the denominator, it becomes
-1 over x squared.
-2 times -2 is +4. X raised -3, when it goes from the numerator to the denominator, x cubed. Does that match up with? Of the two, which one should we use?
Quotient rule.
That's my
Power.
Okay, so quotient is the power.
Whichever you think go first.
Come again?
I think you should have read answer.
I think it depends on the problem.
Very good, Annie. It depends on the problem. The point that I'm trying to make here is this particular problem, if you use quotient rule, you're making things harder than what it's supposed to be. You know, simple power rule would get you to the correct answer. If you're adamant about it, go ahead and use the quotient rule. But the answer will be one and the same. Good. So don't make a problem more complicated if it is not necessary. Good. So this is a rational function, do we agree? So anytime you have a rational function, I said you've got to do something prior to finding the derivative or doing something else. What is that first step? Factoring. Could factoring help in this problem?
Yep.
Yes. Numerator, I can write it as t times t squared plus 3. What about the denominator? Is it possible to factor the denominator? Okay, how? Come again. T minus 1 times t minus 3. Right? If you factor that, you will end up getting did it help in this problem? No. So, for instance, if this had been t squared minus 9, then you could write it as t plus 3 times 3 minus 3, get rid of common terms. Or if you had some t here, you can get rid of it. But unfortunately, this particular problem, we cannot simplify further. So, here is a question. I rewrote it like we always should. Should I use the expression that I factored to find the derivative, or should I just stick with this?
Just stick with
Fix
the
that.
Stick with this, why?
Because you just put in as U and B and then find the derivative, it would be easier.
Okay, I could do UV here too.
Well, it'd take longer, then you'd have to do like product rule.
Very good. So I should just stick with this because if I factor this, sure, I can still keep it as U and V, but to find the derivative, we have to use product, not just simple power. Do you agree? So this is making the problem more complicated. However, this should be the very first step, because in some problems, things would just get cancelled and you can find the derivative easily. With me? Okay, so that approach is going to be painful. So I'm going to go with this. What is the derivative of t cubed?
3t squared plus 3.
Derivative of just t cubed.
Oh, sorry, I was good.
Squared.
No, 3t squared, yeah.
And then the derivative of 3t is 3. B prime, derivative of t squared is 2t. Derivative of 4t is just 4, and then there is negative.
2t.
There, we can just U times V prime and no, sorry, V times U prime minus.
So I could use the standard formula. Since I have V prime, U prime, just plug it in the formula. So V multiplied by U prime, which is t squared, or t squared plus 3, minus U t cubed plus 3t, multiplied by v prime, 2t minus 4. And divide the entire thing by v squared, which is t squared minus 4t plus 3 squared. We took the derivative already, so we don't have to use product again. Unless if we have to find the second derivative. This problem will get more painful. Is there a way for us to simplify this prior to starting? No, I don't think so. So I'll just FOIL, distribute, and get rid of terms. So t squared times 3t squared, 3t raised 4. T squared times 3, 3t squared. Negative 4t times 3t squared, negative 12t cubed. Negative 4t times 3, negative 12t. 3 times 3t squared, 9t squared. 3 times 3, 9. Good. Same process. Negative t cubed times 2t, negative 2t raised 4. Negative t cubed times negative 4, positive 4t cubed. Negative 3t times 2t, negative 6t squared. Negative 3t times negative 4 plus 12t. Good. Divide the entire thing by b squared. Let's erase this side. Well, combine like terms, so I've got 3t raised 4 minus 2t raised 4, that would give me t raised 4. Negative 12t cubed plus 4t cubed, negative 8t cubed. 3t squared plus 9t squared, 12t squared, minus 6t squared, plus 6t squared, negative 12t, positive 12t. Those two would go away. Plus 9. Good. Now, do not FOIL the denominator unless you want to make your life miserable. Like, don't. If you have it in factored form, just leave it as is, which is why I recommended this as well. Factoring has benefits. In this problem, it's just, we weren't lucky, we couldn't get rid of any terms. But factoring is always a great thing. T squared minus 4t plus 3 squared is simply in factored form. Factor multiplied to itself. So leave it as is. Could I factor this? Well, I could try, but at the 4th degree polynomial, why bother? I'm going to leave it as is. Good.
Would this be accepted on the homework as an answer, or would we have a fully?
This should be okay. Unless this 4th degree polynomial is something very simple, then you can simplify. This one, if you want the factor, you can't. Manually, of course.
Okay. Well, thank you, sir.
Manually based on what you've done, but there are ways to factor it. We won't get to this stuff.
I'm surprised you didn't.
Most of you got it right, which is a good thing. So y is x over x plus 1. And u is x and b is x plus 1. U prime, 1. V prime, 1. Derivative of 1 is 0. So y prime is that formula, so v multiplied by u prime minus u multiplied by v prime divided by v squared, x plus 1 squared. Good. So you will have x plus 1 minus x over x plus 1 squared. Good. The x and the negative x will get cancelled. So the answer is 1 over x plus 1 squared. Good. Y prime vertical dash x is equal to 0, or dy over dx vertical dash x is equal to 0 simply means you're taking the derivative and then evaluating at x is equal to 0. This is standard notation. If you do differential equations, you will see this again. So y prime x is equal to 0 would be 1 over 0 plus 1 squared. We will have 1. Good. Are we done yet?
No.
No. We have to find the second derivative. In other words, we want to find the derivative of that. But before I start, I am going to FOIL the denominator and write it as x squared plus 2x plus 1. And you may say, well, you're contradicting yourself. You asked us to leave it as factors, now you're expanding it. Well, I'm doing this here because I haven't taught you chain rule. But this problem can be done using chain rule in a matter of few seconds. But I am going to use quotient rule because we haven't gone over chain rule. So all you have to do is set u equals 1, x squared plus 2x plus 1 as v, and see what the second derivative is. So to find the derivative here, we just have to take the derivative of the derivative to get the second derivative. I strongly recommend that you don't change the formula that we have for each and every derivative. All I would recommend is call this new u and v. Right, this way you stick to the same formula. So u is 1, v is x squared plus 2x plus 1. Put a star here. We will talk about this later on. Chain rule will be easier. U prime would be 0. V prime, derivative of x squared is 2x. Derivative of 2x is 2. Good. So the second derivative, I'm going to stick to the same formula because we redefined the u and the v. So u now is 1 and v is x squared plus 2x plus 1 is 1. So v is x squared plus 2x plus 1. U prime 0. Minus u, which is 1, multiplied by v prime, we get 2x plus 2. Divide the entire thing by x squared plus 2x plus 1 squared. Good. So that first term is going to vanish. So you have minus 2 in common, going to pull 2 out. Have x plus 1 divided by x squared plus 2x plus 1 squared. In this class, it doesn't matter, but again, if you go up, higher up, you may have to deal with third derivatives and fourth derivatives. If you don't simplify at this step, when it is possible, you're just going to make it harder when you go to the third.
Oh, so you don't need to fully simplify the very least the bottom one. Or the denominator. I was.
We can simplify this further. Any thoughts as to how to simplify?
Going to fully go through the very least.
Dave?
With chain rule, x plus 1 and x plus 1 squared.
I see an x plus 1, so I know this can be written as dot because we went from here to there so that we could use quotient rule. Going to go backwards. So minus 2 times x plus 1 divided by that entire term is x plus 1 squared. Yes. And then I'm going to square. What is x plus 1 squared? Squared?
X plus 1 to the 4th power.
X plus 1 raised 4. Yes? That's, and that will get cancelled. So the answer is negative 2 over x plus 1 cubed.
I have a question. So with chain rule, where we use chain rule with the when it's to the second power to the fourth power,
Yes,
which one?
chain rule for the which part?
Like for the next example, like let's say we're gonna do chain rule, would we like you put the 2 over, right, and then you multiply it by the derivative?
Yes.
Oh.
I'm going to the exact same problem with chain rule from the term comes, which is why I said with the start. Good. We have one more step left, which is plugging in x is equal to 1. So y double prime evaluated at x is equal to 1 is negative 2 divided by 1 plus 1 cubed. Negative 2 divided by 2 cubed. 2 cubed is 8, negative 2 over 8 is negative 1. Okay, so numerator is 1 plus x. Denominator 1 plus e raised x. What is the derivative of 1 plus x? It's just 1. B prime, derivative of 1 is 0. Derivative of e raised x is e raised x. Write this formula on your cheat sheet. You get to have one page, so make sure you put this in there. Common mistake, reversing the order of it and missing a negative. It's always v u prime minus u v prime. So v is 1 plus e raised x. What is the derivative of u? It is 1 minus u, 1 plus x. What is the derivative of v prime e raised x? Entire thing divided by 1 plus e raised x squared. Good. I can't simplify here, so 1 times 1 is 1 plus e raised x times 1 e raised x. Negative 1 times e raised x, negative e raised x. Negative 1 times x times e raised x, negative x e raised x. Good. Those two would go away. So the simplified version is 1 minus x e raised x over 1 plus e raised x squared. Should we follow the denominator? No, it's not necessary.
Sir, I'm just saying, I'm just saying because personally, what I did at the very least is I canceled out one of the 1 plus ex with one of them inside of parentheses, leaving me with e raised x minus x times e raised x over 1 plus e raised x. Would that be incorrect?
In other words, you just split these.
In other words, I just canceled out the 1 e raised x above with one of them.
Yeah, but there's some.
Yes, but if you did that here, you've got to do it here also. You can't just get rid of this and that and leave that 100, that's incorrect.
Okay, I was just wondering because I know I did something wrong, but I wasn't sure what.
Yeah, it's a common denominator, so you've got to apply it to both terms. Okay, we found the derivative. So how do we find the equation of the line that is tangent to that curve?
Don't you plug in 0?
Okay, why should I plug in 0?
Because you want to find it at 0.
Okay, so we will get 1 minus 0 times e raised 0 divided by 1 plus e raised 0 squared. That term goes away. This is 1. E raised 0 is 1. 1 plus 1 is 2. Are you okay?
No, you don't.
Okay. 1 is 2. 2 squared is 4. Even before we proceed, at this point, is the function increasing or decreasing?
Increasing.
Increasing, why? What is positive? The slope. So we know the equation of the line. So we plug in 1 over 4x plus b. We've got to solve for b. So when I plug in x is equal to 0, y would be 1 over 2. So b is simply 1 over 2. So we know the slope. We know the intercept. So the equation of the line that is tangent to this curve at that single point is, would this be the, if I move the point, would I still have the same equation?
No.
No, as you keep changing the points, you will get everything. Good.